Okay, and today we are going to discuss a critical yet often underestimated component of the power sector, high voltage transmission systems. Some might call it unsung hero of the power industry. Rarely in the spotlight, but absolutely essential to keeping lights on. Early this year, the blackout that hit Spain and Portugal serves as a stark reminder. When we take transmission for granted, the entire system is at risk. The truth is, high voltage transmission is the backbone of national electricity grid. And as we integrate more variable renewable energy, we can no longer afford to assume that if it isn't broken, it doesn't need fixing. So you know the line, if Alexander Graham Bell were alive today, he would not recognize the telecommunication business. But if Thomas Edison were alive today, and he would certainly recognize the grid. There is a lot of talk and efforts on smart grid, but the fact is that in most countries, the high voltage transmission network still look a lot like they did 100 years ago. Well, the generation business, the electron business have evolved quite a lot. The transmission and distribution business, the wires business has not evolved very much. Consider this. ACSR conductor introduced over a century ago are still the default choice in many transmission projects. After the blackout that hit Spain and Portugal, we heard a lot about system inertia. But the real inertia we need to overcome isn't just technical. It's intellectual, regulatory, and financial. Because one thing is clear, no transmission mission, no energy transmission. Today, we are here to change that narrative. We all explore 21st century solutions for 21st century challenges, focusing on high temperature, low sag, HTLS conductors, a proven off-the-shelf technology that can modernize our grids. We have an exceptional lineup of speakers who will showcase technical solutions and real-world case studies of HTLS deployment in ADB developing member countries, and explain how ADB procurement can accelerate the adoption of those technology. This isn't just about hardware. It's about enabling the clean energy transmission by modernizing very foundation of our power system. So let's dive in and challenging assumptions and find ways to move forward. Let's get started. So we'll begin with our first presentation on HTLS. Please welcome Sudev Subramani. And he is the regional vice president for the Asia Pacific region based in Kuala Lumpur from CTC Global Corporation, the pioneer of ACCC, HTLS, conductor technology. Sudev will share insights from their work in Malaysia, Nepal, and Bangladesh, like ADB cases. Those case studies from the Asia Pacific region perfectly illustrate how innovative technology can overcome development challenges. Please join me in welcoming Sudev.
Good afternoon. I'll just quickly delve into the slides. HTLS conductors, high temperature, low sag conductors. For those of you who do not know what the HTLS conductors are, it's a group of conductors which can operate at a very high temperature, right, while maintaining the sag of traditional ACSR conductors. Traditional ACSR conductors have been there for the last 130 years. It can operate up to about 100 degrees Celsius, but this HTLS group can operate up to 250 degrees Celsius. Now, the ACCC conductor is for aluminum conductor composite core. It's made out of carbon fiber and glass fiber for its core, and you are able to pack more aluminum into the same conductor. Now, this because carbon composite core is light, it's 70% lighter, but it is 50% stronger than steel. So from the picture you can see here itself, it is just, the core itself is the main ingredient here which has been replaced. Now, where can you use this kind of HTLS conductors? Now, HTLS conductors came into existence when utilities wanted to increase the capacity of a certain transmission corridor. In initial days, what they used to do is, when they want to increase capacity, they build a new line. But in more and more countries, what has happened is right-of-way has become a big problem, right? And if you do not want to put a new transmission line, if you don't have the right-of-way, or if you don't have time, if you are going to be building a new transmission line, it can take you anywhere between 5 to 10 years from planning to execution, right? And if you need immediate power, the only way to get you there quickly is reconductoring. And this is what utilities have been doing for the last 40, 50 years when they need power quickly and they have a problem of right of way or time, right? So HTLS conductors can immediately give you 2 times the capacity of ACSR conductor. And because it's got more aluminum in it, it is also much efficient. Right? This is an example from Malaysia. This is a connection line between Malaysia and Singapore. The TNB wanted to upgrade this line from 600 MVA to 1000 MVA. That's a 67% increase there. And they wanted to reuse the existing steel structure. The existing steel structure was 25 years old. They just had to bring the conductors down, bring the hardware down, and pull the ACCC conductors. Very quick. Now, this is what I want to speak a bit more about today. The ACCC conductor or HTLS conductor application for new line. What can HTLS conductors do for new line? One is it can future-proof a new transmission line, a new transmission corridor, right? By giving double the capacity from the beginning. The original way of planning a transmission system is no more applicable, is not as easy as to do as what we used to do before. Today, we have got so many injection points coming into a grid system, right? Especially because of renewables. Last time, you would exactly know where to put your coal plant. You know exactly where to put your gas plant. But with renewables, it would be multiple entries. So what's happening is you cannot plan the capacity of a certain transmission corridor upfront exactly 100%. So you need this additional capacity, and this kind of HTLS conductors are able to give you this additional capacity. And also for new lines, efficiency, right? With more aluminum into the same conductor size, you get less line losses. And with less line losses, you have reduction in CO2 emission. These are things which are not being considered by TSOs these days when it comes to planning of new line projects. The other way HTLS conductors could be used is to reduce the number of transmission towers. This HTLS group of conductors have got very low sag. In that sense, you can put the towers further apart. And if you can put towers further apart, you can reduce the number of towers for the overall project easily by 10 to 20%, right? This is one way you can use it. The other way is you can reduce the tower size, right? You can reduce the tower size. If you reduce the tower size, that means your right of way will be reduced, right? So this then reduces your land acquisition requirements. This is a project from Nepal. It's a 220 kV DC line. Initially, this project was designed as a 400 kV ACSR line, right? But NEA realized they needed more power. So after doing some analysis, they decided to go with ACCC Drake. They automatically got 2 times the capacity, they required. But the other thing which they got was from a 400 kV line, they were able to bring it down to a 220 kV line. And by doing so, their right of way reduced from 52 meters to 35 meters. And if you can see on this picture, this is a mountainous terrain, right? Reduction in right of way helped them a lot, and the project schedule was reduced tremendously. Another project here from Bangladesh. This is a mix of transmission lines. We've got a 400 kV line, we've got a 230 kV, 132 kV lines, right? It's a mix of it. PGCB decided that they wanted the additional capacity for future proofing. Bangladesh being a country where land is a big concern, right? They wanted to overbuild in the beginning itself. So ADB funded project, they were able to do this project with the help of ADB. And for this specific project alone, there has been a CO2 emission reduction of 175,000 tons of CO2 equivalent annually. Now, whenever it comes to planning for a new transmission line, the first consideration by any TSO, transmission system operator, is the first cost. And that's what they are always looking at, CapEx. What's the cost of the conductors? What's the cost of the transmission towers? That's what is mainly they're looking at, right? Now, HTLS conductors carry more capacity in them. This is not being considered. They are always looking at dollar per meter, but HTLS can give you double the capacity. They should be looking at it as dollar per amp per meter or dollar per megawatt per meter, right? That is how we would like TSOs to start evaluating the selection of your conductors, right? And the other thing we want them to do is also look at it as a life cycle analysis, life cycle cost, right? Over a 30-year period, over a 40-year period, how much is going to be the cost of this transmission line, right? Because if you go with HTLS conductors, energy losses should be considered because you're going with a much more efficient set of conductors. And there is going to be CO2 emission reductions. There should be a dollar note put to that CO2 emission reductions, right? Just a very quick calculation here, which I'll give you an example. If you do a total life cycle cost analysis of a project over 40 years, if you place the carbon price at $50 per ton, you could get an ROI within 12 years. And of course, if that goes up to $100 per ton, it reduces. And if it goes to 150 per ton, which is the actual price in use being considered in some utilities in Europe, it reduces. And this would be able to, you'll be able to justify the additional cost upfront. ADB Energy Policy, the ADB Energy Policy 2021 supports these initiatives. Pillar number 1 clearly states, ADB will promote increased efficiency in transmission and distribution networks. Pillar number 2, ADB will support DMCs in building higher resilience in the transmission and distribution system. So ADB supports these kinds of initiatives, right? So before I end very quickly, I'll just like to go through the organization I come from. The organization I come from is CTC Global Cooperation. We are the patent holder for the ACCC conductor. We have first deployed the ACCC conductor 20 years ago in 2005. We only produce the carbon composite core. We work together with 36 conductor manufacturers globally to produce and supply the finished ACCC conductor to the market. To date, we have completed about 1,350 projects worldwide in 65 over countries, and we have got an install base of 180,000 kilometers. With that, I will end. Thank you.
Thank you, Sudev, for the excellent demonstration of ACCC conductor, and also introduce some study cases, including some of them ADB projects, and also the interpretation of ADB's energy policy. Now we will examine another innovative approach from our second speaker, Vincent Wu, the head of Epsilon Cable. APAC and Epsilon Composite. And he will share how their company in advancing modern grade infrastructure focusing on HVCRC. And Vincent will also share case studies in Vietnam and Chad. Welcome, Vincent.
Hi, good afternoon, everyone. As Lynn has introduced, my name is Vincent, and I'm the representative of Epsilon Cable here in the APAC region. I would like to thank ADB for organizing this event and letting us participate in this. So very quickly, I just want to introduce to you guys what Epsilon Composite is. So we are a pioneer in the carbon fiber protrusion process. We started 38 years ago in the beautiful region with a lot of vineyards and chateaux down south in Medoc, France. We are a very technical company. We dedicate about 10% of our annual turnover to R&D. As you can see here on the screen, we are not only doing OHL, but actively participating in 4 different types of industries. Some of the critical applications that we have done here, I would like to just briefly introduce to you. We supply carbon reinforcement rods for deep sea oil exploration, all the way down for more 3,000 meters underseas. And the second to the right, you can see something that is not a UFO, just to clarify. That is Steve Jobs Theater, actually, in Cupertino, California. We supplied beams and struts for the roof there. It's a very huge project, and they needed a very light structure so that they don't need to build walls, and it can only be supported with just glass. And also, we are very proud to be a tier 1 supplier for Airbus. Took us a long time to be approved, and we use the same processes for our aerospace products for all our other products as well. So today, I'm going to mainly be focusing on HVCRC. That's the conductor you can see on the right, bottom in the middle, the glass and carbon hybrid solution. But we also supply a full carbon solution to our partner Nexans with aluminum cladding. It's not very applicable in this region because this kind of conductor is more towards places where there's a lot of ice loading. So for today, we are going to focus mainly on the carbon and glass hybrid conductor. It's this side. So just briefly to explain what is in this course, is basically made out of 3 components, the carbon fibers, the glass fibers, and the epoxy matrix. Basically, the glass fiber layer serves as an insulation against galvanic corrosion. So for Epsilon's core, we have tried to maximize the amount of carbon fiber content because most of the mechanical properties from this kind of core comes from carbon. As you can see, we have designed our core to be roughly about 10% higher than what is required in the ASTM standard. Very quickly, because Sudev have already introduced this technology, very quickly you can see the comparison between ACSR and HVCRC. Low losses, high ampacity, low sag, higher tensile strength. And this has already been spoken about as well, but we just put it a little bit in numbers. They are generic. Obviously, this has to be done country by country because all the parameters are different. Energy mix is different. But I think the important things to see here is the high ROI, return on investment, as Sudev has already mentioned. We focus a lot on CAPEX, but actually, if we switch all the lines to this similar type of technology, we can actually recoup a lot of the investment within a short period of time and use that fund to change other lines. And we are not even mentioning the low CO2 emission. Here we just did a fun fact. For 100-kilometer lines, 10,000 tons of CO2 saved. It's about 4,900 round-trip tickets between New York and London. Very important standards to ensure reliability and safety for all similar type of products. We are proud to be in all the relevant committees, and we are also leading the group right now to make a standard with IEC. Okay, I want to go into the case study, and the way I want to approach this is I want to explain about the reasoning behind why this kind of conductor is being used. And I think I try to pick up on the most relevant issues right now around this region. So the first thing I pick up is the operating of lines for fast developing industrial areas. And this is something that's happening a lot recently, especially because of the geopolitical events between China and US. So many manufacturing industries are moving out of China, actually. It's not only for this reason, it's also lower labor costs in the surrounding areas nowadays, because the cost of production, cost of labor in China generally has been going up for the past decade. So we see a lot of these shifts of this manufacturing like areas coming towards the Southeast Asian region. And this is one of them. This is a project in Vietnam. It's in the Thanh Hoa region. I'm not sure if I'm pronouncing it correctly. But this is the third largest province in Vietnam and is developing rapidly. Industrial index of industrial production has been increasing by 15% annually. The specific project here is a project in Ny Song to Tin Gia. Basically, what is going on in Ny Song right now is there are many industrial parks being set up, and also there's a LNG power plant that is planned and will be in construction soon. So basically, they needed more capacity on the line. The interesting thing to note here is this line was actually built 10 years ago, only 10 years ago. But at that time, if you put into the the planning process and everything, it's basically about maybe 15 years ago when they start planning for the line. And at that time, unfortunately, this kind of technology was not available. So it would be very hard for them to, let's say, future-proof their line. But this is actually a very good showcase on why these HTLS conductors can be so helpful. You will be very flexible to be able to deal with any unplanned situations or scenarios. And for the next, this is the details of the line. It's basically a 17.3 circuit kilometer line, 110 kilovolts. Well, anyways, this presentation will be online, so you can go through it later. Okay, the second case study. This is also an interesting topic that I want to bring up because I think in ADB now, there's an initiative, the Asian Power Grid Initiative, where they are trying to interconnect all the ASEAN countries. This is a very similar case because in ASEAN countries, basically you are bringing a lot of hydropower from the Laos region down south to Thailand, Malaysia, and Singapore. And the idea is to connect all the ASEAN region at a later date. And here in Cameroon, actually, it's basically a very similar idea. So for the first part of this project, it's called a PIREC project. They are trying to to connect the southern grid and the northern grid, the RIS and to RIN, as you can see here. The idea is to eventually bring the power to Chad, interconnection, and then later on bring it to Nigeria as well. One of the main objectives in this project was to connect the Nachtigal hydro plant, which is producing 420 megawatts of hydropower, to Cameroon and beyond. Cameroon is one of the largest country with potential for hydropower. So initially, they were planning to make this line with a AAAC conductor, and they budgeted about 300 million for this project. The funding is coming from World Bank. But later, they plan to add in more hydro plants to the line, so they had to increase the capacity for the future. So they switch over and they make a scenario where they increase the voltage to 400 kilowatts. But the budget was overblown by double. As Sudev mentioned before as well, when you increase the voltage, the width of the line increases. And the interesting thing about Cameroon is usually, well, it depends on the country, but in the case of Cameroon, they don't only pay for the right of way of the towers, they have to pay for the right of ways of wherever the line is passing through. So that exponentially created like a big problem for them if they have to increase the width of the line. So finally, they settled down on a similar situation like what Sudev was mentioning. They went for a lower voltage and they switched over to this HTLS technology, HVCRC, and they were able to reduce the overcost by almost 250 million and increasing only by 50 million. So the interesting thing is this line is about 750 megawatts in capacity, and the whole production of power production of Cameroon is only 1.8 gigawatts. So they have a lot of capacity for future expansion. And they will probably be able to spread this energy all over African region that's next to them. So we worked with our Indian partners for this project. All the details are there as well. Can go over it later. So basically, this is our track record. We have been basically in every continent so far with both our technologies, HVCRC, and also with our partners, LOSAG. Just quickly, I just want to bring you guys, let you guys know about our recent innovations. So we have the core check technology, which basically can enable you to check the integrity of the core after protrusion, after stranding, and after installation. And also, I want to bring your attention to HVCRC Lite. Since CAPEX is a big issue when it comes to new transmission lines for the TSO, we have designed a new core that will be competitive with ACSR because of the reduction of costs over the whole project for either lower towers or longer spans and less towers. So I think this will be an interesting option for new lines that don't require high temperature. And also the last thing that we are working on is the aging model, basically to do a calculation of end of life for the conductors. And that wraps up my presentation. Thank you.
Thank you, Vincent, for the excellent presentation, and thank you for also giving two great cases. And one is related to the ongoing geopolitical tension, and the other one is related to ADB's new ASEAN Power Grid initiative. And now we'll continue our exploration of HTLS. As we turn to our third speaker, and please welcome Luke Ogoshi, and Division Director of the Advanced Conductor Division at Tokyo Rope. Tokyo Rope is a company with over 130 years of expertise in advanced cable technology. Luke will introduce us to their HTLS conductor featuring a stranded carbon fiber core. And today we'll hear compelling cases from Japan, India, and Brazil. And please join me in welcoming Luke from Tokyo.
Hi, good afternoon. My name is Luke Ogoshi, Division Director of the Tokyo Rope International, Japan. It's a great pleasure to join this workshop. Thank you very much, ADB staff. And today I'd like to introduce our technology, HFR conductor, which is using stranded carbon fiber core. So let me explain the future behind this technology. So almost stuff is explained by the staff and Vincent, but the difference is our core is using stranded carbon fiber. So 7 stranded carbon fiber. And using anneal or temper aluminum or thermal resistance aluminum. Or available trapezoidal shape or round wire, which is the same as HVCRC and HTLS. Difference is core. And another difference is easy installation. So it can be installed using conventional tool and method, just like standard ACSR. That is difference. So this is about our core. Thanks to its stranded structure, our core is very, very flexible than steel core. And even during the tight bending, it resists breakage. If damage occurred, it is visible from outside. So it helps improve field inspection and reliability. Next is hardware. So hardware design is almost similar as standard ACSR. It uses compression type fitting with no need for special tool or retraining. So installation time and quality control is similar to ACSR. So this makes HFR easy to adapt, we believe. So this is our basic concept. HFR is just like ACSR, but HTLS technology. Aluminum shape is the same as ACSR. Core shape, same as ACSR. Hardware method is also same. So this is our advantages. So this is design example, but this performance is almost same as HWC and HVCRC. So I will cut this slide. So this business model will be almost same. So we are providing a complete package. So we are providing design consulting service and hardware development service and installation advising service. So we are the technology owner of the total technology. So next is our supplier record. Our global supply, we are supplying from the Asia to North and South America and Europe, including 22 kV voltage to 400 kV, reconductoring and new line. And various private utility and public utility is using our technology. So this track record show ACFR is not experimental technology. It's field proven under the various climate and system condition. Let me introduce our case study. The first project was in Japan, 2002. The goal was 20% capacity increase while maintaining ground clearance. This line is still operation, which is more than 20 years. I think this is oldest transmission line using carbon fiber composite core all over the world. And our utility introduced the evaluation result about this conductor after disassembling of the some portion. And this report show no internal damage about core, no significant corrosion, and continued mechanical integrity. We believe this gives strong evidence HFR is not only high performance, but also durable and reliable over decades. Next is Indian case study, northern India. The 30-kilometer transmission line passed through hilly terrain and military restricted area. As you can see, HFR conductor have to be carried by hand almost 10 kilometers. And the stringing was done by manually. Thanks to HFR's lightweight and flexibility, project was successfully completed. This case highlighted HFR's advantage in remote and restricted access areas. Next is the case study in Brazil. This is also unique. We are using a layout method because the application is across mountain with elevation change up to 300 meters, and the span length is about 1.1 kilometers. So this project proved HFR perform well in extremely hilly terrain application and large span application. So this unique, how do I say, Indian case and Brazilian case. So we can emphasize HFR technology is very, very easy installation. But electric performance is the same. So final, HFR also offer environmental benefit. Its material, carbon fiber resin, polyethylene, can be recycled at reasonable cost. This makes HFR a strong choice for utility aiming to support the circular economy and reduce environmental impact. So we are starting recycling activity from last years. So finally, while electric performance and sag characteristic is almost similar to HCCC and HVCRC, but difference is exceptionally safe and easy installation. That's it. Thank you very much. Yes. And one thing I forget to tell. Yes. So HCCC and HVCRC are great technology. So we believe HFR is also good. So if you have a chance to use HTLS technology, please bring open competition. Thank you very much.
We can see the competition already going on the ground. Let's give another round of applause to Luke from Tokyo Europe. for his excellent presentation on carbon fiber core HTLS conductor and their global applications. Now, for our fourth and final technical presentation, we'll hear from James Ray from Effective Climate Solution of TS Conductor. Unfortunately, due to an unexpected family emergency, James cannot join us in person today. And however, he has kindly prepared a recorded video presentation to ensure we don't miss out their valuable insights. And let's watch the video now, and we'll have time for question later. Thank you.
Tūro. Akarongo mai ki taku karanga. Kia rana katoa. Welcome to today's session, and we'd like to thank the ADB and honoured guests and delegates for coming along today and to hear me speak, and also to hear about the doubling down on the triple up. And so we're talking about improved grid efficiency and security. You know, one of the things that was a quite timely thing to happen today is that, you know, the Callan Clark Foundation, WSP, a leading engineering firm, produced a report. One of their key recommendations is focusing on maintaining and optimising the use of existing infrastructure. And so today, we're doing the same. So what we're talking about here with these conductors is how we can maximise existing infrastructure and maximise the new infrastructure that's being put into place. My background is with Standard Chartered Bank, and I've worked a lot with Standard Chartered Bank in the past and some infrastructure projects. I've worked with Bank of Bermuda, and for the last 20 years I'm involved in companies that are involved in the maintenance sector and focusing on energy transition, whether it be efficient energy within homes and water, or whether it be augmentation or storage. And so we, as part of our process for effective climate solutions, we've talked about Ngāpu Toru, which is taproot, and the approach to ensuring that our communities flourish. And so this is a product that we have looked and endorsed in terms of saying this is going to help your community to flourish as a key part of the energy transition and climate adaptation strategies. So who's this session focused on? Government officials, regulators, economists, CEOs and CFOs, and industry participants. Understanding our advanced TS conductor, and now there's a knowledge gap, and then understanding that your conductor selection drives cost of infrastructure. And that's what we hope to reach today. What areas advanced TS conductor enhanced by increasing capacity, the impact on the grid, how do we compare TS conductor to other existing options? What are the benefits in energy transition and GDP? And we talk about the manufacturing process and case study overviews and a product in a bit more detail. So knowledge gap. How and where to integrate this technology into good infrastructure. Look, this is a transmission and distribution technology. Regulators, you know, and understanding that for regulators, I want you to understand the impact on energy transition. Look, this is about doing it now. It's about having this now. We need this technology in place now. We don't have 20 years, and we need it now. Electricity pricing and wheeling costs, and it has a massive effect on that. The cost of grid infrastructure, you know, realistically, we don't have the time or the ability or the resources to fund this, and so we need to get it right first time. GDP, and in GDP, we're talking about the gross domestic product effects and the positive effects in terms of using this product. Conductor selection for industry participants drives cost. It also determines low cost by businesses and consumers, cost of living, and timing of energy transition, which I've touched on. What areas advanced conductors enhance? You know, when we increase capacity, we allow the network to be electrification. We need to look at, in terms of renewable energy integration, and improves that, about energy storage and retrieval, because it's so good at conducting energy, balancing the grid, reliability, meeting immediate needs of transition, and that's now, right? We need to do it now. Reduce timing and putting this conductor into place. use of existing infrastructure to optimize it, reduction in cost of new lines, less towers and poles, you know, and it all impacts our cost of living, the people that we have, and the ability actually to have energy transition when they're looking at alternatives like coal or fuel in comparison to renewable energy. So we really want to encourage that, and this is part of the process in Jigsaw and business competitiveness. The impact of TS conductor on the grid, number, height, span of towers, and whether you have to alter the towers. Ground conditions, it can be, and I've worked in construction, and it can be really hard getting a tower out of the ground, and the cost of that can be, you know, 4 or 5 times the cost based on where you're putting it and the type of land it's going into. You know, you're consenting, what sort of consenting you have to do, necessity, even if you need new lines, if you've increased the capacity. That's one of the things to think about. The capabilities and install staff required, and numbers, and your people infrastructure, which is just as key important as anything else. Equipment, you don't need any special equipment, not tooling, training of staff. You can use existing methodologies to install this equipment. Maintenance, reduce carbon, and reduce line losses. So how do we compare the advanced TS conductors to existing options? And we're talking about benchmarking on a whole life approach. So you're not looking at the line item, you're looking at all the costs around it, right? If you know you have to put in another 15 or 20 or 30 towers because you're using ACSR, then you should be factoring that into the cost of what this is, not looking at the line item and then building all this infrastructure around it, or altering all these towers around it, and that's how you lead to cost blowouts. We'll cover the case studies a bit later on. What are the other benefits of TS conductor? And so, look, we've talked about cost of living, international competitiveness with your products, the international market, optimization and reliability of existing infrastructure. There's so many ways you can optimize your infrastructure, not only in lines, but we're here to talk about lines. Immediate response today. Ability to undertake energy transition, that you're ready to add these renewables into your network. Your tax base. This has a direct effect on your tax base, how profitable your entities are, whether they can sell internationally, and, you know, the earnings of your local population, and, you know, whether they can afford to buy things, and so much more. So we're talking about more capacity for less capex, modernising the grid with affordable and reliable infrastructure. We're talking about an award-winning innovation, pre-tension carbon fibre core, which is built for transmitting energy. We're talking about it being backed by industry leaders in terms of NextEra and Edison and Quanta. We're talking about ISO certification. We'll build a $135 million factory, and we'll vertically integrate it. So every step of the process we check and we control to make sure you get the same product every time. Every product's X-rayed, and our certification processes are amazing. So, you know, you can come in. We'll welcome you to visit our factory in the United States. It's a next generation advanced conductor. So from that perspective, you know, and when you're looking at it, you're looking at low ethnicity when you first started with it, and right now we're a mainstream solution that can cater to the needs of our next generation and our future grids. We're talking about safety and reliability as a matrix, and so you can see as a picture what it is. We're talking about independent testing for some of the leading laboratories, and in terms of making sure that this product is the highest quality it can be, and that it's reliable. It's easy to work with, and that's one of the things, you know, standard compression, bending radius, standard storage. So it's a standard product that goes into your network. We're talking about, if you look at that, and perfect compaction, you know, and what you're doing and how it's put together, and that doesn't let in any moisture, right? Because of the nature of it. You're looking about longevity and resilience, environmental conditions and snow, fire. The tests and fire are amazing. The moisture, not getting moisture in from marine environments. No, it's built for harsh environments and the environments that we have today, and the wild swings we're going to have in our networks. So reconducting 30 to 40% lower costs, and look, we don't need to alter towers, right? So in terms of that, We had a project we did in Montana, 40% saving constructions, $1.8 million, only 15 miles. We had 10 to 20% lower on fewer and shorter towers and what we do in terms of new lines. You know, base and electric, 183 to 155 towers when compared to ACSR. And, you know, there's a couple of talks I can get you to listen to from Jason and also from Bill Gates, which I really invite you to listen to. In summary, 3 times higher ampacity, less SAGs, standard installation, 10 to 20% CapEx saving, fewer towers, reduced labour, reconducting 30 to 40% CapEx savings, faster deployment, no retrofits, and efficiency, 50% lower licenses for enhanced grid performance. So look, I thank you for coming along. Kia rana, kia manuia, ngā noa te aroa.
Thank you. Thanks, James from TES Conductor for preparing this informative video presentation, which covers a lot, almost all perspective HTLS Conductor. Despite not being able to join us today in person. Now we come to our final presentation of the session, which will equip us with critical implementation knowledge. Please join me in welcoming Keiko, Senior Procurement Specialist at ADB. And Keiko will walk us through ADB's procurement guideline relevant to HTL's project and how ADB procurement approach is supposed to support HTL's technology adoption in DMCs. And this will be particularly valuable as we consider moving from technical solution to actual deployment. Keiko, please.
Good afternoon, and thank you for joining for this session, and thank you for introduction. So the link has already shared, but I mean, you may have a question, why procurement? We are here to listen to the technology advancement. But as you know, that despite the increasing diversity of business model, the public sector still remains a pivotal player in the enhancement and expansion of the transmission networks. So power generation, we may see more of the participation of the private sector still for the transmission, high voltage transmission lines, still the public players plays a role who will be also bounded by the public procurement requirements. And for the case of ADB, that ADB provide we call for the project lending under the sovereign operation, means the ADB lended to the sovereign, and then it will be utilized by like public utilities that some of you are here attending today. So in that case, then for that, in such instances, the employer or purchaser of the HTLS conductor must adhere to the ADB's procurement requirements. So it is my hope that this presentation will provide some insight, then particularly for those coming from the business sector regarding the process that will be applied before your client will be able to purchase and then implement this HTLS. Yeah, like the technology that you heard, that also the ADB procurements also evolve. Maybe it's slower than technology, but we are surely advancing and to make sure that we can provide the procurement options to help our client to purchase the advanced technology. So that's the part I wanted to highlight in this session. So this is the one I just summarized, that this is for the ADB procurement framework. ADB has a procurement policy and then procurement regulations. And for maybe for the business players, the most relevant document would be the standard bidding documents. This is something that ADB require that our DMC utilities to utilize when they're conducting the procurement. All these documents are available at the ADB's website. And in the procurement policy, we indicate there are 6 core procurement principles: economy, efficiency, fairness, transparency, quality, and value for money. I will later highlight for the quality and value for money when it comes to fairness. So basically more for the competition. And I'm glad to hear that there are, for this technology, we have already a competition in the market. So I foresee less of the problem in the sense of the competition and fairness. But nevertheless, I will later touch on the quality and value for money. This is just to summarize the ADB project cycle, and then where at what time that for the procurement team like me participate in this discussion, as well as at what stage that private sector plays a role. So you can see for that there are HTLS supplier or manufacturer, your business opportunity will mainly happening at the implementation of the project. Meanwhile, for the project cycle, that ADB and then the government will require the consultant for the identification of project, preparation of the concept, as well as the preparation of each investment project. So what key matter is, of course, there are already utility who are quite familiar with your technology, but not all the utilities may know, which means that it is important to have a consultancy consultants who are familiar with the newer technology, as well as will be able to present what are the benefit and what kind of this consideration should be there. For example, for that, we talked about the possibility of higher capex. So that aspect need to be taken into the account for the project design. So it is quite important. We have also the strong consultancy industry to help the government, as well as like ADB colleagues, to be more familiar with the advancement of the technology for HTLS. One part for me to tell is like in the procurement specialist will be part of this project preparation stage. We call it for the preparation of the strategic procurement plan. That will be the one that our client, government client, need to prepare. We call for this SPP, which include a market assessment, like availability of the technology, as well as willingness of these market to participate in the tender. For example, for if the scope is smaller, is the international company interested in join? And then is it for the EPC type will be more attractive for the market, or actually that it will be the more efficient to reach out to the manufacturer and purchase the conductor as the goods package. Yeah, it really depends on the project specific, but that kind of the specific requirement of the project need to be discussed and then need to be translated into this SPP. So one part I think you may already know, but for the ADB's case, for the loans and grant, that the procuring entity is the government, and they are the one to sign the contract. So ADB will review the procurement document, and of course we support the government to going through the bidding procedure, but the owner of the procurement action is the government. This is for the international best practices. As I said, for the open competitive bidding for this HTLS, I don't see much of the problem because I already see the competition here happening, so it's okay. But not every technology have this luxury of the competition. If it's for really emerging and it's still at the pilot stage, sometimes the ADB provide technical assistance, which is inclusive of the pilot component. And in that case, ADB may work together with the government to purchase and then really test the technology. So that kind of option is also happening. Sorry. When it comes to value for money outcome, and then I'm glad to hear that from you that you're already presenting the benefit of life cycle cost, as well as like the way of differentiating the bid part efficiency. So that kind of matter will be quite important. And then for this SPP process is also the part of our initiative to deliver the value for money, because sometimes not just the one infrastructure, but the utility may want to have additional value through the project. For example, sustainability constellation is one point, and maybe the sustainability constellation means it can be also like an environment impact by the reducing the right of way, can be also the sustainability constellation, as well as like longer the life cycle of the infrastructure is another the constellation. So for that matter, that ADB has this, we are promoting the usage of quality-based evaluation techniques. For example, merit point criteria, we call for it MPC or life cycle costing. So currently we are already offering the option to our ADB borrower to apply this the quality-based evaluation techniques that they will be able to differentiate the bids with higher quality with some additional value addition. So for this merit point criteria for the ADB that starting 2025, we make it as this is as default evaluation method for the higher value works packages. In case of small island countries, for example, in the Pacific or the Maldives, that this use of MPC is already default method for the evaluation. So I just wanted to send a message that the ADB is also really trying to promote this, the quality-based evaluation, and we are here to help further our client to really, let's say, acquire the quality viz as well as like value addition. For example, maybe there's something to be delivered by this HTLS. Quickly, that I think that some of you have already mentioned about the cases of the ADB financed project using that HTLS. One point I just wanted to invite attention is mode of the procurement. So as I said, some of the cases that our borrower is comfortable going for the purchasing the conductor as the goods package, and they separately the procured works, means for the installation, or maybe if it's for the new construction, that they also find the contractor doing the installation as well as like installation of the tower. But I would say more common approach is a turnkey approach. So for that case, for the business player, it's the critical part is finding the partner, an EPC partner who will be able to really present the total value of this infrastructure, and will be able to also, of course, this EPC contractor need to have a good track record to be able to qualify for the criteria. But that will be, I think you have already know, but if you are new for the joining in the IFI funded project, that will be the final advice from me before I concluding the presentation. So in short, the message I have is, yes, in addition to the ADB, the energy policy, even for the procurement, from the procurement policy, procurement initiative, we are also ready to support this kind of adoption of the quality infrastructure. And we appreciate that this dialogue with the market to really learn that how ADB also can offer the procurement options are really fit to the market development. So thank you very much.
Thank you, Keiko, for that very comprehensive and practical guide to ADB's procurement process. You have given us a clear pathway to turn those innovative conductor technology into reality across our member countries. And we are now open for the floor for questions. Before I open the floor for questions, let me invite all the speakers to the stage, please. we do receive some questions online, and I think we first open the floor for questions from the audience here, and to help everyone follow the discussion. And I'd request when you ask a question, please state your name and your organization and your question. And who would like to start from the floor here? Please.
Thank you. And thank you very much to all of the speakers and to you, the moderator. Thank you very much. Great insights. A question, please, to Keiko. Thank you for the insights into the description on ADB procurement policy. And interesting to see that, you know, that the ADB organization is using the quality-based evaluations of technologies, which we in the business of HTLS conductors, we would hope will continue and expand. But I would point out perhaps that it would be useful from our perspective and progressive if ADB would stop specifying the old obsolete technology in many of your projects. So for instance, without naming the countries, I can tell you that ACSR is specified in many of your transmission projects at the moment. And in a way, I'm not being critical, I just think it might be a progressive move to open up the specification to allow HTLS solutions from the assembled group of manufacturers here. Thank you.
Okay. Thank you very much. I think it's not really a question, but a statement. Meanwhile, the part I'd like to highlight is before the bidding document is prepared with maybe specifying the technology, there is the long process of project preparation, right? And then when it comes to that, the preparation and actually the owner of that, the decision is really the utilities. ADB is the lender. Of course, we have a discussion. Meanwhile, it's more for the borrower who will decide for their own project whether that they are, so that's the process. I think more for the discussion of this open technical specification or alternative technology adoption is need to be really coming from the borrower. We are here to share the information, market development, and some the good example, and like this event like this, with inviting the many utilities from our member countries to disseminate information, for them to start considering that option. So for that matter, that I think that thank you for the statement. Yes, I agree, it will be nicer. Meanwhile, from the procurement person, that idea also need to come from the borrower, right? It's not ADB bidding document. It's the borrower's bidding document and their project. So I hope the business as well as the utilities can also work together, and we're happy to support for this, the idea of trying the new technology. Thank you.
Thank you, Keiko. Anyone else from the floor?
My name is Tika Limbu, ADB, Energy Specialist. I have one question on the last presentation on ACFR. The conclusion, the summary is very interesting. Like it says that 10 to 20% saving in the capex due to the ACFR. But we thought that the capex would be higher compared to the ACSR. But how does this technology would lower the capex in the transmission line? This is my one question. And of course, I also see that 50% loss would be reduced due to this innovative ACFR. That's true. But since the comparison I can see here only for the high voltage line, 132, 220, 400, but the loss in the system occurs at the lower voltage, MB or LV. Did we not try this? Because this is so flexible. This is so easy to string like ACSR conductor. It's very handy. then why don't we introduce this into the network where the losses happens more? Most of the losses, if you look at the network, it's all, mostly in the low voltage or medium voltage, 11 kV, 400 volt, volt. So that's number 2. More questions. Huh? Number 3, because I see that this ACCC was very common, like in Bangladesh, in Nepal, but now I can see that SVCRC, ACFR, AECC, it's all very innovative. But I just wonder whether we have some comparison of this 4 latest technology. I think this question may be to Dan. Thank you.
Tika, thank you for the questions. I think for the ACFR question, maybe James can answer, but if any of you would like to, no, maybe Dan. I'll ask Dan to respond.
No, I think that question was with regards to the 50% in line losses and 20% reduction in capex. That was the TS presentation.
Yeah. Yeah.
Yeah.
Yeah.
Yeah.
Yeah. Okay. So I think what I understood from that, and I haven't seen James's detailed numbers on that, but the reduction in capex. Keep in mind, he's talking about the entire cost of a new build transmission line. So it's the towers, the conductors, and the insulators. So the capex reduction is mostly coming from reducing the number of towers, and that's enabled by increasing the span between the towers. So we saw, I think, Sir Dave, the number that you showed, you're going from 350 meters span to 385 meter span. So we're increasing the span 10%. Theoretically, we're reducing the number of towers by 10%. The key point is that that I would take away from all that to emphasize this on the loss reduction and the value. So if we look at dollar per meter or dollar per kilometer installation cost, and that's all that we do, then we haven't done our job. So we need to look in consistent with ADB's value for money and the procurement principles and ADB's energy policy, where it talks about efficiency and resilience and climate change and all this good stuff. We need to look at life cycle value. So we need to look at that dollar per amp per kilometer, dollar per megawatt per kilometer. If we don't do that, and this addressing Tom's point, okay, ADB is a knowledge bank, and ADB is supposed to be helping its borrowers figure out what's the best value for money. So I know the project you're talking about, and I've talked to the people, some of the people involved in it, and said, why did you let the borrower specify ACSR? And it's because the ADB energy specialists, who shall remain anonymous because they're not here to defend themselves, is because they didn't do their homework to learn what's available in the market. And it's a sad statement, but other divisions, other departments of ADB, I see some people here who also shall remain unnamed, who've done some of these projects that Keiko referred to. So we've been talking about this in ADB since 2009. How is it that ADB energy specialists don't know what's on the market? Okay.
Because see, because we are at the ground, so we are working with this HTLS. This is happening. It's happening, one by one, incremental. But since what we are trying to do is like trying to assess the incremental cost of HTLS versus the ACSR. And we are trying to say that we are trying to get tap some grant funding as well for the incremental cost. I think you know that. But since the overall life cycle cost would decrease, then where is the incremental cost then? It is decreasing. Then why do we need money? That kind of concessional fund for developing the transmission line with the STLS. It's lower cost.
You're the first one who mentioned concessional funding.
Yeah, and grant, not concessional.
Yeah, well, grant concessional funding. It's not necessary.
Yeah, I think
it's not. No one that talked about that. No one mentioned that. You're assuming. Are you assuming that it's necessary? It's not. It's
then,
not,
then
it's
we
not
need to
necessary.
we need to relook at our assessment of the sector then, because we are saying that it is costly. It's 50% more costlier, but it has got 100% more.
Maybe I'll chime in here.
Okay, please.
Let me chime in here.
Yeah, maybe I'm not very aware of this happening, the cost factor. Yeah.
I think this whole thing started because of that last slide. Please disregard that last slide. Right? I think the three of us here can agree. Now, if you have seen my slide and what Vincent has also said, right? For reconductoring projects, this is a slam dunk. We don't need to discuss about it. HTLS or composite core conductors, doesn't matter whichever technology that is, it's much cheaper to reconductor, right? It's only 1/3 of the cost. But what we are pushing for is for new line application. And that is where we are calling for the life cycle cost analysis. You can reduce costs by the number of towers. You can reduce about 10% or 20% of the number of towers, right? Or you can reduce the size of the towers. CapEx wise, it'll come down a bit, but it was not going to be cheaper than ACSR, because as you said it clearly, if it's cheaper than ACSR, we would have been implementing it now. All these utilities sitting here would have implemented it, right? That is why we are pushing for a life cycle cost analysis, because utilities today are still looking at only CapEx. If you take the savings of the energy losses, if you put some dollar value against CO2 emissions, then it starts to make some sense, right? Because there's also a consideration when it comes to generation. If there are less line losses, there is also less water used, and we are getting more and more into trouble of water for generation. You have to put that into consideration. Like what Keiko has said, reduction in the right of way, right? You're cutting down trees. Now you're going to cut down less trees, less social impact. Shouldn't we be putting values to this? And that's what I like, this approach which ADB is taking now, that if you're taking all this into consideration, then HTLS would make sense for new line applications. But if you're just going to look at CapEx, you're absolutely right. HTLS is still more expensive.
But that is okay.
I can't say this enough, okay, because on a dollar per meter basis, the conductors are more expensive. But if you want to calculate a life cycle cost, you don't need to spend $1 million and hire a PhD economist to do this. You take the total CapEx, you take the total megawatt hours of throughput on a line using an indicative megawatt rating and an indicative loading, which the borrowers, which the transmission companies know how to do. And you can calculate a lifetime number of megawatt hours throughput. And you can also consider the losses and do ACSR versus ACCC. I could do this for you in a day, okay?
No.
And what you will find out, what you will have to agree to, is that ultimately my arithmetic is correct, and that on a life cycle basis, the value for money is not with ACSR. ACSR is technologically and economically obsolete, and that's the point Tom was making. ADB should not be financing it anymore. If ADB finances a building project or a lighting project, they will not specify incandescent light bulbs because they're obsolete. And ADB would not finance compact fluorescent light bulbs. ADB would only finance LEDs or something that's better if it's available.
Yep, then I agree, because now the energy policy is in the process
Thank you,
of
thank you.
shaping.
Due to the time constraint, I think
Yes.
let's stop here. And we really appreciate the healthy argument, which will help us, everyone, to understand better why we need to use advanced technology, right? We do have a few questions online. And the first one is, I would like to ask, could you please focus on how HCCC could reduce the line loss? I would ask Sudave to answer this.
Good question. Basically, there's two ways, right? Like what we have all explained, carbon composite core is much stronger than steel core. And for any given conductor size, we are able to reduce the core size. So our core size would be smaller than the steel core size, right? And then the second thing is ACSR use round wires. whereas we use trapezoidal wires. So because of these two characteristics, we are able to put in more aluminium into the same conductor size while maintaining the weight not to exceed the ACSR weight, right? That's number one. Number two is also the aluminium we are using annealed aluminium. Like what Vincent has said, we use annealed aluminium, which is a much softer aluminium, which is much more efficient. So combination of additional aluminium and the type of annealed aluminium we are using, that gives you that 20 to 30% reduction in line losses. Right? Thank you.
And HFR has the same function.
We can see the ongoing competition. Thank you, thank you. And actually, we have another few questions, actually. And one of the question, I think Luke probably can help answer that. Do the upcoming rated criteria in the evaluation process have any impact on adopting carbon core conductors? I don't know if this evaluation focuses on procurement or whatever. So the question is not that clear, but yeah, the question is, do the upcoming rated criteria in the evaluation process have any impact on adopting carbon core conductors? I also think it's not very clear question. Okay, if you can, sir, if you can clarify.
Actually, I would like to know that now the criteria is that pass-fail criteria. Now the evaluation process is pass or fail. But when it will come to merit point rating, then what will be the impact on choosing the carbon fiber core conductors? If there any impact, it will affect positively or it will affect negatively, that we cannot choose any carbon fiber core. Another, there are some other HTLS conductor, like invar conductor, also HTLS conductor. Whether those can come to the scene.
Okay. For the merit point criteria, that again, it's not one size fits all that we have started for the criteria. Is the idea of like allocating, let's say, the weightage for the technical component and the price component. That weightage is also really depends on the situation. But when you're part that I'm not really familiar with these chords and how it can really translate it into the technology difference. But for example, if it's about like you will be able to quantify for the efficiency. So as the purchaser, you will be able to indicate this is the minimum or the efficiency that the system need to deliver. And then for any other bit, which can offer the even higher efficiency, you will be able to give more like credit to that particular bit. So if you can translate that the certain technology into more for the benchmark you can really compare for the efficiency, and then I think that that's how the MPC or even actually for the life cycle cost, the approach can help. And for the MPC, that in addition to the technology, I think that big value addition is about the sustainability, or another part is like local participation criteria. So this kind of like just go beyond just the infrastructure part can be greatly valued through this MPC approach. Thank you.
Thank you.
Thank you.
I have some couple of more questions. One is same like Tikalum Limbu was telling that I find that there are 4 manufacturers, 2 almost same. That means CTC and I think Epsilon. I don't find any change in the construction also. But there are some change in the ACFR and TS. So could you tell that what is the how to choose, how we can define in the specification? It is a dilemma for us.
I think this, for us personally, I think right now we see a lot of utilities requesting basically experience or references from the cable manufacturer in terms of supplying to any specific utilities. This happens a lot. But rather than the hardware manufacturer, I think if utilities can specify the experience of the core manufacturer, they could request for something that maybe for like projects in countries where they have similar like climate situation. I think that will help other manufacturers to be able to supply to the utilities. Right now, I think there's a lot of focus on the cable manufacturers' experience. But as you know, this technology is not 100 years old like ACSR. So a lot of cable manufacturers might not have those experiences yet. So if the requirement is only based on the cable manufacturers, then it becomes difficult for the other core manufacturers to be able to participate. I hope that answers your question.
Yeah, I think one more question, that may be the last one. We are using a CCC since 4 or 5 years or more. And this is a great conductor. We are facing, say, sometimes we transmit 600 ampere old conductor. We have replaced the conductor with equivalent CCC, and we were able to transmit more than 1100 ampere in the same line, only changing the conductor. That's a great relief for us. At the same time, we have some, that means negative sides of these conductors. Some voltage issues there. So I would like to ask you that how to eliminate this issue. Another issue is the maintenance. Maintenance, that means if there are some snap in the conductor, then our local expertise, there is no master installer, only one master installer in Bangladesh. So how to make it easier for us? This is the question.
Maintenance. So I think as this type of technology of conductors become more widely used, the utilities' own maintenance teams should be trained, right, to do this kind of repair works. And you eventually you would not need third-party supervision like how we are currently providing. Your own team should be certified to carry out this kind of maintenance works. And the first question was, sorry. Oh, voltage, yeah, sorry. I'm not very sure about that actual specific scenario. Maybe we could take this offline with my colleagues later. Thank you.
Thank you, thank you. I think before we close, there is a question. Vincent, probably you can help quickly respond. And does Epsilon have authorized a strander? And if yes, how many and name of those company, please?
There are quite a lot to name. So basically, it depends on what country we are talking about, because we have qualified cable manufacturers in almost like 10 countries now, almost 15 to 16 cable manufacturers. So it really depends on which country. Feel free to contact me to ask. For hardware, we are basically partnering with the two major suppliers in the world, PLP and SICAM or DAVO. And there are some more depending on local requirements that we are speaking to right now to increase. But mainly with PLP and SICAM so far.
Thank you, Vincent. And thank you all for those excellent questions and for your active participation throughout the session. And Your engagement truly reflects the importance of modernizing our transmission infrastructure. Let me take a moment to thank all our distinguished speakers today. And your expertise has given us both the technical solution and the implementation pathway we need to accelerate HTLS adoption. Now I'm pleased to hand this floor over to my colleague Dan Millison, and consultant from ADB, also chair and organizer of this session, who will summarize today's key takeaways and offer closing remarks. Dan, please.
All right, I'll just sit here since we're really out of time. Just quickly, we've got, I think, consensus from the vendor side, from the technology supplier side, that ACSR is obsolete, and I firmly believe that myself from my own experience. In terms of value for money, advanced conductors are something ADB should be supporting and promoting, and ADB should be a bit more proactive during the project preparation stage when the procurement plans are developed. I think the case, the value for money case, when we move beyond the dollar per meter and do a dollar per megawatt hour, dollar per amp, dollar per megawatt in a simplified life cycle basis, if we don't do that life cycle, that dollar per amp per kilometer, dollar per megawatt hour basis, then we're not being consistent with how we evaluate generation or distribution in terms of our cost, economic and financial analysis. So ADB needs to do a little bit better, but I think, to be honest, the transmission utilities have to drag ADB along, because a lot of the ADB energy specialists simply don't understand the technical details. They're economists and finance people. And it's just my observation, okay? You fire me if you want, but we've got multiple, this isn't new technology. It's been commercially available for 20 years. ADB has financed multiple projects, mostly in Southeast Asia. But if we look at where HTLS conductors are mainstreamed in other countries, like in Vietnam and Indonesia, ADB is not getting requests for financing much for transmission projects. The utilities are doing this on their own. Like in Indonesia, PLN has been doing upgrading, I think mostly with HCCC for 10 years now or longer. So I think the key thing is doing this life cycle cost analysis, value for money, consistent with ADB's procurement guidelines. The one thing that was mentioned just quickly is on the greenhouse gas emissions. So ADB is still looking at climate change and the energy transition. We need speed and scale. So in the wires business, in the grid business, we need speed and scale in terms of capacity to get more and more renewable energy, and especially more and more variable renewable energy onto the grid. And the fastest way to do that is in reconductoring. And that's where the value for money is, obviously. You can't replace ACSR with ACSR unless you do a complete rebuild in an existing right-of-way, or you build a completely new line and tear out the existing lines that you've got. That makes no sense financially, technically, or economically. Tika, I'll address the one point Tika made about the line losses. Yes, in most of the DMC, in most of the developing member countries, most of the line losses are in the last mile in the low voltage network at 11 kV and 400 volt. That's not what we're really talking about with this. With the HTLS conductors, we're talking about the high voltage network, 11 kV and higher. Those are the key points, and I will be writing up a summary that we'll post along with the presentations on the website. Thank you very much.
Thank you very much. Thank you.